Now, good day. Welcome back to Apostle 1 tutorial. Now, today too, I'm going to continue with the special angles. Yes, 0 degrees, and then from then I'll move on to 90 degrees. Now, this one is critical and one of the controversial aspects of trigonometry. Now, let me lead you through how we can get the angle 0 degrees and how we can find the sine, cosine, and the tan of the 0 degrees. Then we move on to the other degrees or the other trig ratios. Now let's look at it carefully. Now let me consider a right angle triangle. Now let's consider a right angle triangle. Let me consider this right angle triangle. Pay attention carefully. Let me consider this right angle triangle. Let me label the vertices A, B, ABC. Now, let me consider here to be an angle theta. Okay, let me use okay, let me consider this space to be an angle theta. Now, with this particular angle, how can we get an angle theta? The angle to be 0. Now, don't forget that the moment here is theta, then here becomes my opposite. The opposite becomes the BC, hypotenuse is still AC, the adjacent is what? It's still AB. Please make sure you like the video, then you share. Open your eyes carefully. Now, of course, if here is 90, then here plus is supposed to give us 90 degrees, right? Yes. But we don't know the angle for this one. We don't know the angle for this one. We only know that this one is a right angle triangle. We don't know the length for this one, the length of this one. You understand? So follow me closely. Now, how can we get this angle to be 0? How can we get this angle to be 0? Now, this angle can never be 0 just like that. This angle can never be 0. Unless you look at the limit where if this particular line is approaching the line BC. So let's look at it carefully. Unless I try to bring this particular line down, you see the line AC, unless I try to bring the AC down, unless I push the AC from here to here. So if I push the AC from here to here, I'm going to get the line as this. If I push the A from here to here, this is what I'm going to get. Now, the moment I push the C from here to here, this angle becomes small, right? Now, when I push it from here, now here is A, here is B. Now, when I push the C from here to here, what happened to this particular angle? The angle theta. The angle theta will become very small. You understand? Don't forget the hypotenuse is still what? AC. The hypotenuse is what? AC. So we are going to look at a situation where the C is approaching the B, where the angle A will be approaching 0, because the moment the C comes to the B, the moment I push the C, the moment I push the C from here up to here, what will be the angle C? There is no angle for C. The angle for C becomes 0. The moment we push the C from here up to the B here, the angle A here, the theta here becomes what? Becomes 0. Because as we are bringing the C down here, the angle for the A, that is theta, will be very small. So the moment we bring this one to here, the angle becomes what? 0. And that is how we can get the angle 0. Otherwise, we can't get an angle 0 from here. You understand? So, what I want to say is that as the C approaches the B, the angle 0 becoming very small. So when the A become straight away to the B, when the A, we put the A up to the B here, what is going to happen? The angle A, that is theta, becomes what? 0. The angle theta becomes 0. That is where we can get the angle theta. Now, the moment we push the C up to the what? To the B, the moment to push the C up to the B, then it means that the distance from A to C will now be the same as what? AB, because the C is now pushed from here to what? To the B. So AC is now the same as what? AB. And that is where we can record the angle to be what? 0. So the angle can only be 0 if AC is equal to what? BC. Now, so let's look at it. So as we push or we locate C toward B, or as the C approaches what? The B. As the C approaches what? The B, the theta approach 0 degrees. Look at it very well. The theta will be approaching what? 0 degrees. The theta approaches 0 degrees. And then as this one is moving from here to here, the AC, the A to C, the length of AC also becomes same as what? AB. I hope you are following very well. Look at something. Now, whilst we are pushing this one from here to here, the theta becomes 0, just as what I said here. The theta becomes 0. That is 1. As we push the C to B, pushing the C to B, the theta becomes 0 because there will not be any angle when the C pushed from here to here. Now, another thing you have to know is that what will be our AC, the hypotenuse AC? Don't forget that hypotenuse doesn't change. The hypotenuse AC, now the AC here now becomes what? The AB, because AC now becomes the same as what? The AB. Now, another thing you're supposed to know is that where will be our BC? Where will be our BC? Now, the moment the angle becomes 0, it means that the BC is at the same point, so therefore the BC becomes 0. You get it? So it means that the BC becomes 0. BC is equal to 0 because at this particular point, the distance from B to C is just a point. So BC is 0 because the C is on the B. That is the situation we can record an angle 0. Now, at this particular point, how can we find, if I want to find sine theta here, what will be sine theta? From here, sine theta is equals to what? Opposite is equals to BC divided by AC. I hope you are following. Now, what will be cos theta? From here, cos theta is what? Adjacent AB divided by hypotenuse AC. Now, let's talk about tan theta. Now, what is tan theta? Tan theta is what? Opposite BC divided by what? Adjacent AB. Now let's look at this one carefully. Let's look at this one carefully. Now, from here, look at it very well. Now, as this one approaches here with this particular condition, don't forget that the theta will be approaching 0. So this one is the same as the theta will be approaching 0. So as the theta will be approaching 0, we're going to get sine 0, which is equal to the opposite, which is BC. Now, what's going to happen to BC? Now, this will be our BC, right? Now, BC. As approaching 0, don't forget that the BC will be here, from here to here, right? And the BC will be approaching 0. You get it? So sine theta, the BC will be approaching what? 0. And what is AC? AC is becoming what? AB. You understand? The AC becomes the same as what? AB. So which means the AC and then AB, they are all what? The same. You get it? Yes. So meaning our AC is the same as what? AB. Now, at this particular point, what is our BC? The BC will be becoming 0. So we're going to have 0 over AB, which is equals to what? 0. So at any moment we have sine 0, it is equal to 0. Anytime you have sine 0 is equals to what? Is equals to 0. Because 0 divided by any number is 0. I hope you are following very well. Now let's come to the cosine. Cos of the angle theta. Now we said that as the theta will be approaching 0. Now the theta will be approaching 0. Now when theta is approaching 0, what happened? Theta is equals to what? AB. What is our AB? AB is this side, right? Divided by the AC. Now don't forget that as this one will be approaching B, the AC becomes the same as the AB. Don't forget AC becomes the same as what the AB, meaning the AC and then the AB, they are the same. So this one becomes AC. The AC becomes the same as what? AB. Don't forget that the AC becomes the same as AB. So which means AC and AB, they are the same. Now, so what are you going to get here? AB divided by AB, we are going to get 1 over 1. And 1 over 1 is 1. So anytime we have cos 0 is equal to 1. Now follow me closely. Now let's talk about tan 0. Tan 0. Now tan is BC over AB. Now where is BC? BC is from here to here. So I'm going to write my BC. BC doesn't change. It is the AC that becomes what? The AB. Now I divided by AB. This is my AB. This is my AB. Now what is BC? When this one becomes 0, the BC becomes what? BC becomes 0. Don't forget the BC becomes 0. The BC becomes 0 divided by what? AC, AB. Now for that matter, what is 0 divided by AB? 0 divided by AB is 0. Now, so this one means that anytime you have tan 0 is equal to 0. So you can use your calculator to confirm everything that what we are talking about is true. Use your calculator to confirm everything. You get it? Now, at the same point, let me talk about the other trigonometry ratios. Now, because of that, we can look at cosec 0. Now what will be cosec 0? Cosec 0. Don't forget that cosec is 1 over what? 1 over sine 0. Cosec 0 is 1 over sine 0. Now don't forget that sine 0 is 0 over AB. So we have 1 divided by 0 over what? AB. Now this one will be the same as what? AB divided by 0. Now, any number divided by 0 is undefined. I hope you understand, yes. Because this one is 0 over what? You get it? Or we can even go straight away. Because I wanted to show you from this particular point. Now we can even go straight away. Now sine 0, we're going to get 1 over. What is sine 0? Sine 0 is 0. So this one will be undefined. Or not defined. Or infinity. Because 1 over 0 will not give us an answer. It will be undefined. Not defined. That is infinity. Now, let me move on to sec 0. What is sec? Sec is 1 over cos. So sec is 1 over cos. So we're going to have 1 over, what is cos 0? Cos 0 is 1. So therefore, sec 0 will also going to give us 1. Now this top up is for relative math student. Now let me talk about cot 0. Now don't forget, cot is the same as what? 1 over tan 0. You get it? Now we have 1 over, what is tan 0? Tan 0 is 0. So which means cot 0 is 1 over 0, and 1 over 0 is also undefined. Or not defined. Or infinity. Infinity. I hope you understand. Yes. So look at this and very careful. Look at it very careful. Because there's no way we have to, the only way we can solve for angle 0 is when we apply the limit. The only way we can solve for the angle 90 is when we apply the limit. So look at this and very careful. Now let's move on to how we can find the angle 90 degrees. Let's see how we can find the angle 90 degrees. Now, let me consider the same rectangle triangle. Now, here is 90, here is A, here is B, and this side is C. Now, let me consider this angle to be theta. Now, I hope you understand this thing clearly. Now, how can we get 90 degrees? The theta to be 90 degrees. No, we don't use this one for any discussion. This one shows that the particular triangle is a right angle triangle, so you don't have to base on this one. Now, I want this particular angle to be 90 degrees. Now, how can theta be 90 degrees? Now, look at something. Now, if this one's supposed to be 90 degrees, unless I push the angle A to B, look at something. If I decide to push the angle, now this one is A, here is theta, here is B, and then this side is C. Now follow me closely. Now the moment I push this A from here to here, what is going to happen? The angle here will be bigger than the angle here. The theta will become big. You understand? The theta will become big, the angle theta. So if here is very small, the theta will become very big. Now let's move on. Now the moment I move this angle A up to the B, the moment I move the angle A up to the B here, What is going to happen here? It means that the theta now becomes 90 degrees because at this particular point the angle is 90. So as A approaches the B, so as the A approaches the B, the angle theta becomes 90 degrees. Becomes 90 because at this particular point the angle theta will become 90 degrees. As you are moving here, it will be approaching. So when it comes here, the angle from here will be 90 degrees. So the angle theta will be 90 degrees. Right? Okay. Now don't forget this side is C. Now what is our BC? Don't forget, as we are moving here from here, the BC becomes the same as the AC, right? The BC becomes same as AC, meaning BC and AC going to be equal. Look at BC and look at AC, it's going to be equal. Now the last thing is that what will be our AB? Our AB will be 0 because they are all at point B, so the AB becomes 0. So we have our AB will become 0. Now, so let's go ahead and let's see what we can do here. Now, let's solve for sine what? Sine theta. Now, from here, sine theta is what? Opposite BC over hypotenuse AC. You understand? Follow me closely. Now, what about cos theta? So we can even go straight away. Then we do it. What about cos theta? Okay, now let me move straight away, then I'll do it. Now, sine theta is equal to AC. Now, so as the theta approaching 0, we're going to get sine 0. As the theta approaching 90, we're going to get sine 90. Now, what is sine 90? It is still BC over what? AC. Now, what is BC? Don't forget that BC becomes the same as AC. So, our BC becomes the same as what? AC divided by AC. Now, what is AC? AC divided by AC is 1. So, it means that sine 90 is equal to 1. Sine 90 is equal to 1. Keep it in your head. Don't forget that sine 90 and cos 0, they are complementary angles. So sine 90 and cos 0, they are also the same. Don't forget. Don't forget that cos 0, we had 1. Now let's look at this one. Cos theta. Now what is cos theta? Cos is what? Adjacent AB over hypotenuse AC. Now, as the theta approaches 90 degrees, the angle approaches 90 degrees, what is going to happen here? The AB, we're going to still have our AB divided by AC. Now, what is our AC? Now this one, can I move straight away? What is our AC? The AC is the same as AC. Now, why can't I? Let me move further. Now, as cos 90, cos the theta approaching 90 degrees, what is going to happen? The AB becomes 0. So let me go straight away. 0 divided by AC. And you can see it clearly that 0 divided by AC is still 0. So cos 90 is equal to 0. Now let me talk about tan 90. Now let me talk about tan 90. Now tan is TOA, adjacent Adjacent is AB divided by tan is what? Opposite rather. Tan is opposite. The opposite is what? BC. Over adjacent. Adjacent is AB. Now, oh, sorry. Now I'm going to talk about tan theta rather. Tan theta. Now, as the theta approaches what? 90. So this is tan theta. Now, as the theta approaches 90, what is our BC? Our BC becomes the same as AC. So our BC here becomes the same as what? AC. And then what is our AB? Our AB becomes 0. Now, what is AC over 0? Now, this one becomes undefined. Or infinity. This one becomes undefined or infinity. So tan 90 is also undefined or infinity. I hope you see the proven, right? Now, let's talk about the other trigonometry ratios. Let's talk about sec 90. Don't forget the sec is the same as 1 over what? Cos 90. You understand? Yes. So we're going to have 1 over, now cos 90 is 0. So it means that 1 over 0 is also undefined. So it means sec 90 is undefined or not defined or infinity. I hope you understand. Now let's move on to cosec 90 degree, which is 1 over sin 90. Cosec is 1 over sin 90. So we're going to have 1 over, now what is sin 90? Sin 90 is 1. Sin 90 is 1. So it means that cosec 90 will also give us 1. Now go and check the previous video for you to know that the cosec 90 is the same as sec 0. And then sec 90 is the same as cosec 0. They are complementary angles. Now, so cosec 90 is equal to what? 1. Now, let's move on to cot 90. Cot 90. Now, what is cot 90? The cot 90 is the same as 1 over what? Tan 90. Now, don't forget tan 90 is undefined, right? Tan 90 is undefined. Now, let's look at something. Let's look at something very well. Now, I don't want to start from there. Now, don't forget tan 90 is the same as what? AC over 0. So, let's look at it very well. Because I can't write undefined as a denominator here. So we're going to have 1 divided by tan 90. Now tan 90 is AC over 0. Now let's reciprocate this particular fraction. We are going to get, now let me reciprocate this particular fraction. We are going to get cot 90 cot 90 equal to 1, change this one to multiplication, reciprocate the second fraction. We're going to get 0 divided by AC. You get it? Now this one gives us 1. This one gives us 0 divided by AC. Because 1 times this one will still give us the same as this one, right? Now at this particular point, 0 over any number is still 0. So therefore, when we have cot 90 degrees, we are going to get 0. You see, this is very simple like that. This is how come when you have tan 90, it is undefined. Now, this is how we can prove all the trigonometry ratio from 0 to 90 degrees. If you've not checked the 45 degrees, go to the previous video to go and check 45 degrees. Go to the previous video to go and check what the 60 and then the 30 degrees. Now, see you in the next video on how we can apply these trigonometry ratios. Bye bye.